In this video, we'll illustrate the process of problem solving using Newton's second law. The problem is as follows. A man has to slide a crate across a floor by pulling on a rope. He is taller than the crate, so the rope makes an angle of 32 degrees with the horizontal. The crate has a weight of 1,150 newtons, and he initially pulls with a force of 172 newtons. Initially, imagine that we use rollers, so that friction can be neglected. And we are asked, what is the normal force exerted by the floor on the crate, and what is the acceleration of the crate across the floor? The process of problem solving with Newton's second law always begins with a diagram. The first step is to draw a diagram showing all of the forces acting on the object. Looking at our problem here, we can think about the number of pushes and pulls that are taking place on the crate and draw our diagram. So we start by drawing the crate. These drawings do not ever have to be intricate or fancy. They just have to show the forces that are involved. One force that we can almost always rely upon is the gravitational force, mg, which in this case is equal to 1,150 newtons. Since the crate is resting on a surface, the normal force is acting on the crate, and since the surface is horizontal, that means the normal force is going to be vertical. And then the final force in this part of the problem is going to be the applied force, or the tension in the rope. So we have the rope going off here at an angle of 32 degrees to the horizontal, and the tension is along that rope also at an angle of 32 degrees to the horizontal. And so now we have drawn a diagram showing all the forces that are acting on the crate. Remember, there is no friction in this first example. The second step in the problem-solving process is to select a coordinate system. In other words, what do we mean by the x direction? What do we mean by the y direction? And what is positive and negative along both of those axes? It's usually a good idea to have the positive direction be the direction that the object is going to move. And we can tell by looking at this situation that the crate is going to move in that direction. So it's probably a good idea to call that the positive x direction, horizontal to the right in this diagram. Then the y-axis is always perpendicular to the x-axis, and we will just arbitrarily select positive as up in the y direction. So we've selected a fairly standard coordinate system for this particular application. Step 3 in the problem-solving process is to ask the following question. Given this coordinate system, are there any forces that need to be resolved into components? Well, looking at the three forces that we have here, there are two forces, the weight force and the normal force, that are purely vertical. They do not need to be broken up into components. However, the tension force has both x and y components, and we can draw those as the horizontal component, Tx, and the vertical component, Ty. Now we need to come up with formulas for those components using the trigonometric functions. We begin with the sine function. The angle is 32 degrees, and the formula for the sine function is opposite over hypotenuse. Looking at this triangle, we remember that the x and y components make a 90-degree angle, And so the angle 32 degrees, opposite that is the side TY, and the hypotenuse, the side opposite the 90-degree angle, is the tension T. Notice I haven't put in any numbers yet. Always do algebra before you do arithmetic. We can then solve this equation here for the y component by multiplying both sides by the tension. And that gives us the result that the y component equals T sine 32 degrees. Similarly, we can use the cosine function. Cosine of 32 degrees is adjacent over hypotenuse. The side which is adjacent to the 32-degree angle is the x component of the tension, Tx, and the hypotenuse is still T. Once again, we multiply both sides by the tension force to get Tx by itself, and that gives us the result that the x component of the tension is going to be T cosine 32. So now we have completed step 3. We have broken up the tension force into components, and we have written out formulas for each of those components. And then the fourth step in the problem-solving process is to use Newton's second law to figure out what you need to solve for. Looking back at the problem statement, we see that we are asked first for the normal force exerted by the floor on the crate, and then for the acceleration of the crate itself. We turn to Newton's second law to help us find these. Remember that Newton's second law is actually two equations. One for the sum of the forces in the x direction, equaling mass times acceleration in the x direction, and another one for the sum of the forces in the y direction, equals mass times acceleration in the y direction. We can keep the x and y components separate from each other. The first task is to find the normal force, so that leads us to take a look at the y forces. We realize that the acceleration in the y direction is going to be 0 because the crate doesn't move up or down. As far as vertical motion goes, the crate is stationary. So that means that the sum of the forces in the y direction have to add up to 0. When looking at vertical forces, the crate is in equilibrium. Well, we see that there are 1, 2, 3 forces acting on the crate in the y direction, 2 up, 1 down. And so, when we go to sum those forces, we see that the normal force is up, positive. The weight force is down, negative, and the y component of the tension force is up, positive. Since these forces are in equilibrium, we get the result that the normal force is equal to the weight force minus the y component of the tension force, and that is going to be 1,150 newtons minus the tension times the sine of 32 degrees. The tension in the rope is 172 newtons. So we can plug that value in there, along with the sine of 32. And that gets us the result that the normal force exerted on the crate by the floor is 1,060 newtons, to 3 significant figures. We are then asked, what is the acceleration of the crate across the floor? Well, that acceleration is going to be in the x direction. So we're essentially being asked to find the acceleration in the x direction, and we can use Newton's second law in the x direction for that. Looking at our diagram, we see that there is only one force in the x direction, and that is Tx. It's in the positive x direction to the right, so when we go to sum up the x forces, that's all we have on that side of the equation. And that's going to be equal to the mass of the crate times the acceleration in the x direction. We pause for a moment because we are not given the mass of the crate. However, we are told the weight of the crate, and since we are told that mg, the weight of the crate, equals 1,150 newtons, we can solve for m by dividing both sides by 9.8, and that gives us 117 kilograms for the mass of the crate. So now we can say that T cosine 32 equals the mass of the crate times the acceleration in the x direction. Therefore, the acceleration in the x direction is 172 times the cosine of 32 degrees divided by 117, and that gives us an acceleration in the x direction of 1.25 meters per second squared to 3 significant figures.